All right, I want to show off another breadboard project that I did recently. What we have is, what I did was I bought a cheap multimeter. It didn't have a capacitor tester in it. And I thought that would be an interesting breadboard project to learn a little bit about the equations behind computing capacitance. And so it turned out it was kind of interesting. So my tester is a little more sophisticated. I end up using these Arduino nanos that I had around. They don't have Wi-Fi or anything, but they do have an AT Mega 3 something something chip, the standard Arduino chip. This particular one is a clone of the Arduino Nano, and it has sufficient pins that we can control a OLED display. And this particular one I think is 120 by 60, if I'm not mistaken. Actually, yeah, 120 by 60. So it is sufficient to display the capacitance in farads. And the key to the equation is you have to have a known resistor value of specific ohms. So one of the recommendations was use a 10,000 or a 10K ohm resistor, and that's what I started with. So I have this 10K ohm resistor that is, I just put it over here on this side, that goes between the D13 and the A0. So the A0 pin is going to be where we can measure analog pin, where it can actually measure the capacitance as it's charging. And then I also have an additional 220 ohm resistor here for the discharge capability. So that's going to take that A0 output and have this ability to discharge out when we pull the D2 pin low. So that's basically where we're at here. Is it the D2 or D12? Anyway, whichever one it is. Yeah, and D2 we're using for a reset. So we actually added a reset button just to make it a lot easier. So the question is, will this actually power up? And we can show it working to start with. Excuse me, folks. So now, hey, power is on, no smoke. This is good. This is a little bit of a jury-rigged combined two half-size breadboards together, plugged together. So it's a little more delicate than I would like, but let's flip it around so it's just the display is viewable. And here we are, capacitor meter. So we know how to write text to this particular OLED display. That's good, but now what about the capacitor? Well, the capacitor is not in yet, because what we have is a capacitor right here, an electrolytic capacitor that we don't know the value for. So we're just going to plug this in and see if it can compute the value. I actually know the value of this one, but just for testing's sake. The important thing for using electrolytic capacitors is they are very sensitive to making sure that you plug in negative to negative and positive to positive. You can easily burn out your capacitor and possibly your finger. So this is kind of important also in capacitors with higher capacitance. It is a battery. It takes some time to discharge. So if you don't fully discharge it and you touch it, you could get a little zap. This particular one is such a little tiny thing. It's not really a worry for this. But I do know which way is ground. In a standard breadboard configuration, we have this blue rail, the outer rail for negative and the inner rail for positive, clearly marked by a nice color. So I will plug in the short end to negative, and that's going to be correct. And then the positive is going to go to the A0 pin that we can use to actually read its value over time. Okay, it's plugged in, and it still says capacitor tester, so we have to actually press reset. That's the instructions at the bottom. And there it is. Okay, so it came up with 32.5 microfarads. I happen to know it's 33 microfarads, and that's perfectly fine. Within a margin of error, this computation has worked. If I reset it again, it can compute a little bit differently over time, but it comes back to around the same value. So that's the capacitor tester. Nice little project. If you want to see the sketch, I will leave a link to my GitHub channel to take a look at the sketch and also the wiring of the Arduino Nano to both the OLED display and the various resistors that I have and the button for reset. Hopefully I did that. Otherwise I will. Thank you very much.